For this lesson, we're going to focus on some vocabulary related to special pairs of angles. We're going to focus on complementary angles, supplementary angles, and vertical angles, and we'll be taking a look at a proof of the vertical angle theorem. So here we can see a pair of complementary angles. Complementary angles are angles whose measures sum to 90 degrees, and here we can see the two angle measures are 65 degrees and 25 degrees, and 65 and 25 do sum to 90, so these angles are complementary. I do want to point out that because they happen to be adjacent angles, they're sharing side PB, that these two angles together are actually forming perpendicular lines. Their non-common sides are perpendicular lines. However, I also want to point out that to have complementary angles, you don't have to have them be adjacent. You could have a 65-degree angle here and a 25-degree angle over here, and as long as the two measures sum to 90 degrees, the two angle pairs will be complementary. Let's take a look at the next vocabulary word, and that one is supplementary angles. These two angles here are supplementary because they're forming a straight angle. We know that this is a 180-degree angle right here. So these two angles are supplementary. Once again, the two angles don't have to be adjacent to be supplementary. We could have a 90-degree angle here, for example, and a 90-degree angle over here, and these two angles would be supplementary. It's just the fact that they sum to 180 degrees that makes them supplementary. And now let's talk about vertical angles. We have two lines here that are intersecting, lines DC and BA, and so they're forming this X, and when they form this X, we have a top angle and a bottom angle, and a left angle and a right angle, and the angles that are opposite each other, they share the common vertex. The angles here across from each other are congruent. They don't have any sides in common. Angle ATD and CTB don't have any sides in common, they just have this common vertex, and their non-common sides are forming straight angles. These two angles here are congruent, so if this angle here is 30 degrees, then the vertical angle to it is also 30 degrees. And then we know that these two have to add to 180 since this is a straight angle, so these two angles are supplementary. That would make this angle 150, and then the same thing over here. If this is 30, this angle would have to be 150, and so we can see that the other vertical angle pair as well is congruent. So we actually have a theorem that says vertical angles are congruent, and we're going to take a look at a proof of this right now. So we know that the very first statement in any proof is the given. So we're going to say that angle 1 and angle 2 are vertical angles. Those are the angles there that are marked in red, vertical angles. And our goal is to actually prove that those angles are congruent. And notice I have another angle that I've numbered, angle 3 here in blue. We're going to use that piece of information. We know that angle 1 and 3 together form a straight angle. They're adjacent angles. And we know by the angle addition postulate that the measure of angle 1 plus the measure of angle 2, the measure of angle 3 is equal to 180. And we know that the measure of angle 2 plus the measure of angle 3 is equal to 180. And that's by the angle addition postulate. It's actually the second half of our angle addition postulate. And if you take a look here, I can see that both of these statements are equal to 180. Both the measure of angle 1 plus the measure of angle 3 and the measure of angle 2 plus the measure of angle 3, both of those are equal to 180. And since those two expressions are both equal to 180, I can set them equal to each other by substitution. So I'm going to say the measure of angle 1 plus the measure of angle 3 is equal to the measure of angle 2 plus the measure of angle 3. So that's by substitution. And then here, notice that on both sides of our equation, on the left and the right, we have the measure of angle 3. So those two things are equal on both sides of the equation, so we can subtract those out. And when we do that, we would just have the measure of angle 1. If I subtract the measure of angle 3 from both sides, I'd have the measure of angle 1 is equal to the measure of angle 2. And that's by subtraction. And if you think about it, we're close to being done here. We actually wanted to prove that angle 1 was congruent to angle 2. But if I say the measure of angle 1 is equal to the measure of angle 2, that's actually the definition of congruent. The angles are congruent. So I can finally say angle 1 is congruent to angle 2. And the reason for that is definition of congruent. If angles have the same measure, then they are congruent. So we've just proven the very first theorem in this class, which is that vertical angles are congruent. Don't forget to do the survey at tinyurl.